When companies laid off thousands of workers citing artificial intelligence, they believed they were cutting costs forever. Now, a specific group of executives is starting to regret that decision. But their pain isn't about lost code or missing features in an app. The real problem is that they fired the very engineers who understood how to run these systems on expensive hardware. They thought AI was just software magic. In reality, large language models are heavy industrial machines requiring specialized GPU and TPU architectures. Without those specific human experts managing the physical constraints of silicon, their infrastructure begins to collapse under its own weight. This isn't a story about coding efficiency or algorithm tweaks. It is a fundamental misunderstanding of what it takes to run an AI product at scale. The narrative that AI replaces humans suggests you can swap expensive senior engineers for cheaper software hacks and junior developers who know how to call an API. That logic works in theory, but it fails catastrophically when the rubber meets the road. You cannot code your way out of memory bandwidth limits or thermal throttling without deep architectural knowledge. Companies that bet on this shortcut are now facing a reality check, where their inference infrastructure simply cannot handle the load they tried to automate with less staff. The root of this failure lies in an economic trap known as the demand externality. Research by Falk and Tsoukalas reveals a structural flaw in how firms approach automation-driven layoffs. When a company replaces workers, it captures 100% of the immediate cost savings on its own balance sheet. However, those companies only bear a fraction of the resulting loss in market demand. They dump the rest of that economic damage onto their competitors and the broader ecosystem. This creates an automated arms race where every firm cuts staff to save money while simultaneously eroding their collective capacity to operate effectively. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This dynamic traps organizations in a cycle where they lay off more personnel than is collectively optimal for the industry as a whole. They are cutting the very talent needed to maintain stability because they view labor as a variable cost rather than a critical asset for system design. The result is an environment where companies are desperate to cut costs, yet their operational capabilities degrade faster than their savings accumulate. It is a classic case of individual rationality leading to collective irrationality. Compounding this economic error is a profound cognitive bias among decision-makers who treat AI as an infallible authority on their own behavior and business strategy. A behavioral study involving over 1,300 participants found that when subjects viewed the algorithm as an authoritative predictor, they were 34% more likely to forego guaranteed rewards based solely on the belief in its accuracy. The data shows a significant confidence interval ranging from 2.45 to 4.70 regarding this increase in risk-taking behavior. This psychological bias led executives to overtrust narratives that AI could do everything cheaper and faster than human oversight. They assumed they could swap a team of experts for an algorithmic decision-maker without realizing the physical engineering requirements needed to actually deploy those systems at scale. The belief that software alone solves hardware problems caused them to ignore the massive infrastructure costs required for inference. When the system hit its limits, there was no one left with the specific knowledge to optimize it because they had laid off the architects who understood the trade-offs between different chip architectures and memory management strategies. The gap in these companies is not a lack of code, it is a failure in system design. As AI capabilities continue their rising pattern, moving toward near-universal proficiency by 2029, the complexity of managing these systems increases exponentially rather than linearly. The engineering reality is that large language model capabilities rely entirely on massive computational infrastructure, specifically clusters of GPUs and TPUs. Managing scaling and inference latency requires deep architectural expertise to ensure the hardware performs efficiently under load. As we look toward 2029, when task completion rates are projected to hit between 80 and 95%, the need for engineers who understand hardware-software co-design will only grow more critical. Companies that laid off these specific roles in favor of cheaper solutions are now facing infrastructure bottlenecks they cannot solve with software hacks alone. You cannot simply write better code to fix a memory bandwidth bottleneck caused by running an oversized model on undersized silicon without understanding the physical constraints of the chip you are using. This shift signals a major change in career value for developers and engineers. The role that is being automated is the code monkey, who focuses purely on application logic without regard for deployment efficiency. However, the engineer who understands how to make that code run efficiently on expensive silicon has never been more valuable. These are the people companies will be scrambling to rehire or retain as their automated arms race hits a physical wall they cannot bypass with software alone. The verdict is clear. You do not lose your job because AI becomes smarter than humans in writing text or generating images. You might lose your position if you only know how to write code without understanding the hardware that runs it. The regret coming from these companies comes from realizing too late that they fired the people who knew how to build the factory, leaving them with just blueprints for a product they cannot manufacture efficiently. The engineers who understand the why behind chip choices and system trade-offs are now the ones holding the keys to stability in an AI-driven economy. As the gap between theoretical capability and physical execution widens, those with deep architectural insight will define which companies succeed and which fail. The era of treating AI as a cheap software patch is over. It has become a domain where hardware mastery separates the survivors from the casualties. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.